Okay, everybody, let's listen up. Shh. Remember, we're doing 83, which is simple probability. You've been doing simple probability a long time. It's the number of outcomes desired over the total outcomes is how you find your probability. If we have a dice, okay, we're going to do the probability that we roll a 5. It would be one outcome is the 5 over 6 total outcomes on a dice. So our probability of rolling a 5 would be 1 over 6. Sorry about my voice. The probability of rolling greater than 4 would be a probability of 5 and 6, right? So that would be 2 outcomes over 6, or 1/3 of a probability. Shh, Wesley. All right, so whenever we have all of the probabilities involved in any single event, like if we were to say the probability of each one of the faces of a dice, it would be 1/6, 1/6, 1/6, all the way down. All of the probabilities must total to what?
1.
1. All of the probabilities must total to 1. The probability is always between 0 and 1 inclusive. If you have a probability of 0, that means it can't happen. If you have a probability of 1, that means it must happen. Okay? So those are the, you can't have a probability of 20. You can't have a probability of 100. It's 100% because that's 1. All right, so if I had 2 fair dice and I was trying to find the probability that something was happening and something else was happening, that's when I multiply the 2 probabilities, which is shown for you in example number 8. Okay, so it says, what is the probability of getting a 7 rolling 2 fair dice and the probability of getting an 8? Now they're looking for 2 different outcomes. This is not really a combined problem. They're looking for 2 answers, an A and a B answer. Okay, so if I was going to say I have 2 fair dice, then I'm going to go to my little 6x6 chart where I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Right? We have our little lines lined up like that. And we make our little chart that's going to go 1 plus 1 is 2, 2 plus 1 is 3, 4, 5, 6, 7, 3, 4, 5, 6, 7, 8. 4, 5, 6, 7, 8, 9, 5, 6, 7, 8, 9, 10, and so forth. How many of these are going to be 7s? 1, 2, 3, 4, 5,
6.
How about you? So it's 6, thank you. 6 over 36, or 1/6 of a probability that we're going to be able to get a 7. Okay, so then what is the probability of greater than 8? So this is going to be a 9, 9. This is going to be a 10, 10. It's going to be 11, 11, 12. Okay, so probability of greater than 8 means that the 8 is not included. So that line gets crossed out. But we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Possibilities greater than 8. So we would have 10 over the total number of outcomes, 36, is going to reduce to what? Divide by 2, 5/18. And 5/18 would be the probability of greater than an 8. Any questions on that? Now, the last thing on just simple probability is when you are looking at 3 events happening or 2 events and you want the probability, say you're flipping coins, and you want the probability that in 3 flips, you will flip a head and a head and a head. What is your probability of 3 heads in a row? And whenever you're doing this, this is talking about a head and a head and a head. Okay? And anytime we have that type of problem, we're going to take the probability of a head, 1/2, times the probability of a head, 1/2, times the probability of a head, 1/2, and we wind up getting 1/8 is your probability of getting a head and a head and a head. And you could see that if you did a little tree. You start out with a head and a tail the first time, and then you have another head and a tail and a head and a tail, right? And then from each one of those, you have a head and a tail and a head and a tail and a head and a tail and a head and a tail. So your paths produce 8 different outcomes, and only one of those outcomes is a head, head, head. So 1 out of 8 is the probability. So you could have done it with the tree diagram, but that is simple probability in a nutshell. So next we're going to do